Okay, good morning to one and all. Okay, today, okay, good morning, each and every student. Today we are going to start second unit that is called Big Data Analytics. The second unit only focus just basic fundamentals of Hadoop clustering setup and writing map-reduce programs, and also some other basics of map-reduce programs. So these are the only three topics will cover second unit. It is also purely or completely fundamentals and basics. The first chapter only introduction, just already discussed about how to define Hadoop and what are the big data characteristics and how to define the big data, and coming to the some basic building blocks. So these are all the things you already discussed in the first chapter and the first unit. The second unit to only focus, we have to set up, we have to prepare a particular environment that is called clustering environment. Such a cluster has some set of machines. Those machines will play as a name node, as a data node. So that is a distributed environment. So that distributed environment will going to create, will going to set up by the Hadoop. So that is called we have second unit only focus, only concentrate three basic topics: environment prepare, and also write the map reduce program, and also what are the requirements, the essential requirements to fulfill the map and reduce program, to prepare the program. The next one is Hadoop environment setup. It is uh, completely depending on your based on three modes. So before we start the those environment setup, especially it is done by the three modes. First, let us discuss Hadoop. I already discussed in the first unit, but in the remaining utilities, in the remaining how many utilities are there, how many libraries are there, so what are the modules are there. So these are the essential concepts we are also going to discuss in this second unit. Then you have to start real configuration or a setup or environment preparation that is done by the, we have three modes: standalone mode, and pseudo mode, and fully distributed mode. Finally we have to configure some XML files. Okay. Next, second topic, what you are going to start the second topic to write the map reduce program. We take the real world data set. So we have every time whenever you open the mobile phone, we get some analysis. We get some information about weather report. Because of this data set or this database, every second or every minute going to prepare, going to collect all the weather information. So, how to analyze weather information regarding latitude, longitude, and humidity, wind, wind position, and all the information we collect and also keep in a weather data set. So, on the weather data set, we apply the some analysis. So that is done by the map reduce program. How to write the map program, how to write the reduce program, and start the analysis and start the computation across the weather data sets. And coming to the after write the program, we need some interfaces, because every time we have to communicate with the data node and name node. That's why we need some interfaces. And finally, third topic will introduce some devices, some hardware drivers. So you know the driver code, mapper code, reducer code, recorder code, and combiner and partitioner. So you already know JDBC, ODBC. If you want to access the data, real data, we need some JDBC, ODBC drivers, Java database connectivity, and Open database connectivity. The same manner in this commodity hardware devices or basic building blocks, we are going to use such driver concept. So yeah, already the first unit already discussed about Hadoop. So Hadoop is a big data tool. It is advanced technology. Especially this Hadoop will introduce some new concept to store the any kind of data, any size of data, any structure of data. And also whenever you store the such volumes of data, such a large amount of data, we need a particular framework that is called processing tool. Such processing tool can able to process any kind of data, any type of data. That's why Hadoop will introduce Hadoop was introduced by the Doug Cutting. Okay, it is one of the other. The two others are there. Doug Cutting and Michael J. Cafarola developed this new technology. It is called Hadoop. And this Hadoop not only store the data, not only process. First, the essential feature is to prepare to create the distributed environment and parallel environment. Such a distributed environment can support, can help to store the data, to send the data, to process the data, and also such type of computation, such type of task will be complete within the deadline, because of the Hadoop will provide the distributed environment. So that is the beauty of distributed environment. The work will be complete within the deadline, and also the work will be finished very easy way, because of parallel processing is there. Because of distributed manner, we can distribute the things across the thousands of clusters, across the thousands of nodes. So that is the beauty of Hadoop. So that I already discussed about how the Hadoop will achieve the name, because of duck cutting sun has twice there. The toy name is Hadoop. Okay. Next one is Hadoop. Basically, Hadoop is a basically it is a open source. It's completely open source, and this open source will provide some set of utilities. So that's why any this Hadoop is suitable to any competition, any organization, any applications. So this software utilities and facilities, you can prepare any cluster, whether the cluster is a single node or multi node. So, and the second thing, Hadoop basically it consists of two components. The first component is the storage part. That storage part is nothing but HDFS, Hadoop Distributed File System. The second part or second component is the processing part. The part is done by the MapReduce. The MapReduce it is a framework. It is a software. It is a programming model. And coming to the so this Hadoop, how to design, how to start the designing and start the competition. First, you have to try to design the a particular cluster. Okay, that cluster is nothing but in the real world, the cluster is nothing but it is a collection of, it is a group of objects, similar objects. But in this situation, in this scenario, so such a clusters is based on the, or designed based on the commodity hardware. The commodity hardware means a machine. Okay, number of machines will form a cluster, will form a particular network. Okay, so the on the across the such cluster, across the those machines, we start the execute the map and reduce program. Then the things will happen. The things will finish. Next one is first initially, if you start the distributing the data, first you have to take the large file or take the data. The data will prepare as a file, as a file system. After prepare the file system, just you have to apply the splitting or partitioning concept. The large file will be partitioning or partitioned into a number of blocks. Each block size is 128 MB. After partitioning is completed, we get thousands and millions of blocks. So those data blocks, just you have to send to across the thousands of data nodes. So that time, the Hadoop play a key role as a distributed manner, as a distributed file system, because it is very smoothly to distribute the each data block across the or over the data blocks or data nodes or machines or clusters. There is no bandwidth issues. That is the beauty of a distributed file system. And next one is so the entire code, the code is nothing but map code and the reduced code. So this map program and reduced program, and also shuffling and also partitioning. So these all the software packaged code will execute, will run in the parallel process manner, parallel process manner. So that's why even though we have 1 terabyte data is there, even though we have 100 terabyte data is there, very smoothly, very easily, the Hadoop will going to finish their job because of distributed, because of parallel. So that is the Hadoop. Why the Hadoop play a key role in this digital world, or a number of applications or number of organizations, because of the nature is distributed and because of the way of processing, the way of computation in the parallel manner. Next one is same. Whenever the large data set is there, we have to use some set of clusters. So those clusters very easily store the each data block, and also very easily distributed and very easily and processing. So that's why the Hadoop allows distributed processing. So from the distributed processing, we can achieve so many concepts. Data is availability, and also there is no fault tolerance, and also replication factor can support whenever the fault tolerant will happen, and also throughput, you can gain the good throughput because of distributed processing. Next one is the Hadoop is designed to scale up from single server to thousands of machines, and each offering local computation and local storage. So that's why the Hadoop is not only single technology. It is feasible, and also the way of working automatically scale up the machines. So for example, one of the we are going to start a particular organization issue. So initially we start 1,000 machines, and the way of the competition is going on, and the meanwhile those machines are not sufficient to complete that particular competition. So we add many machines to store the coming data. So that's why in the meanwhile, whenever the competition is going on, during the such time, we add the some set of machines. So that time Hadoop is very feasible, and also Hadoop is can able to support such new machines. And Hadoop has two major layers. We already discussed about the processing and also computation layer that is done by the MapReduce. The MapReduce only perform processing and computing the things, and Hadoop HDFS only focus store the data, store the data sets or objects. And the coming today class, the new thing is about Hadoop. Hadoop framework is completely composed of four modules, completely integrate with four modules. Those are called Hadoop Common is one of the module. This module going to support some necessary services, necessary requirements. Next one is HDFS. You already know about HDFS is a storage component to store the data. Next one is Hadoop Yarn. Yarn is YARN. Yarn means Y means at, A means another, R means resource, N means negotiator, yet another resource negotiator. So in this resource negotiator, we have to manage the resources. We have to schedule the some particular task. Next one is Hadoop MapReduce. So among these four modules, you already know two modules, HDFS and MapReduce. Only two modules are new. That is called Hadoop Common and Hadoop Yarn. So Hadoop Common is nothing but it maintains some set of libraries and some necessary utilities. You know the value of utilities. You know the value of libraries. Without the help of necessary or required libraries and utility, you can't can't complete the our computation. That's why whenever you handle any computation, we need some set of libraries. That's why whenever you write the program, just you have to import some files. Those files are available from the libraries. Okay, import some libraries. Next one is utilities. If you want to perform basics things or advanced things, we need some utilities. So those utilities are we are going to use. Next one is HDFS. We already discussed HDFS. HDFS is a Hadoop distributed file system. Hadoop distributed file system. So voice is audible. Anybody, please respond at chat box. Okay, okay. Thank you, thank you. So now Hadoop HDFS means stores. Okay, thank you. Uh, Stores data on the commodity machines. Okay, commodity machines means very high-end devices, very inexpensive devices. So whenever you want to form a cluster, just you go and take the machines. That is, machine is nothing but a host. A machine is nothing but a domain or a data node. And then you can, the HDFS is ready to store any kind of data, any amount of data. And finally, the HDFS providing very high aggregate bandwidth across the cluster. So that's why one of the beauty of HDFS, how the HDFS will going to handle thousands of data nodes or thousands of machines or number of clusters, because of bandwidth is there, because of bandwidth, and also distributed environment is there, parallel processing is there. So that's why HDFS, how it is handle a large amount of data, a terabyte of data, petabyte of data, because of bandwidth is there. Next one is Hadoop Yarn. You already know about Yarn. It is a particular scheduler. How the scheduler will decide which task or which job is going to run or move to the running state. That is done by the some scheduler. Same manner in this environment, we handle some set of resources, and also we have to schedule the those resources to each application or a number of applications. That is done by the yarn at another resource negotiator. It is purely manage some set of resources in every cluster, and also scheduling user applications, schedule the application, which application will going to run, when the application will going to start. So these are the things will control by the this yarn. Next one is Hadoop MapReduce. You already discussed about this is a programming framework or model to process the data. And the last class, we already discussed it many times, Hadoop features. So just to once again, you a little bit discuss about Hadoop features because the coming topics, all coming topics are based on the Hadoop. So that's why if you know if you start the Hadoop designing, just what are the features of Hadoop? So first feature is very interesting feature. Why the Hadoop is popular? Because of open source. So open source is nothing but the code, the software code is available free of cost. So that's why there is no burden to achieve Hadoop, to have the Hadoop, because of every organization, every application very interestingly use the Hadoop because of it can play a key role, and also it is purely open source. Next one is our Hadoop. Hadoop will design where you can design the Hadoop, where you can implement the Hadoop features because of clusters. So such cluster is highly scalable. So because of cluster is to maintain the to integrate the to combine the some collection of some set of machines. So okay, those machines are today's machine quantity is size is 1,000. So those 1,000 machines are not suitable to store the data, to process the data. That's why you have to increase the machines. So that's why automatically the cluster size will be increased. Scalability, we need scalability. We require scalability. That's why we have two concepts are there, two approaches are there, horizontal and vertical. So horizontal is nothing but we can add the number of nodes, number of machines. That's why we can achieve the scalability. At the same time, we also need some power. Okay, that is called CPU power and RAM power. That's the vertical approach. Vertical approach we can help us, can guide us whenever the scalability is not sufficient. That time, just you have to increase the RAM size and also CPU power. Okay, so these two concepts will guide the scalability of each cluster. That is the beauty of second beauty of Hadoop. Next one is fault tolerance. So whenever the faults will happen, definitely or frequently faults will happen because of we have commodity hardware devices. Definitely commodity hardwares will not work in the meanwhile. Whenever the competition is going on, definitely in the middle of the competition, some of the nodes doesn't work, some of the nodes doesn't send any replication factor, mean any heartbeat situation, heartbeat signals. So that time simply those data nodes are dead. So that's why we follow the replication mechanism, replication process. The replication process means the same data we have to place multiple places. Even though one data node is not support to get the data from that node, just we no need to stop the competition, just we go to the second place and third place because of replication factor is there, can support to achieve the same data from the different place. Next one is high availability. So even though failures will happen, so data is available to the user. That is called high availability. Next one is effective, because of it is purely open source, and also no need to maintain very expensive or very advanced hardware devices. Just we use very inexpensive and also purely commodity hardware devices. The Hadoop will start the working. Next one is fast data processing. So because of the real world data is very large, if you take the Facebook organization data or Amazon organization data, the data size is very large, very volume. So that's why we need fast data processing. So day by day, every customer try to no need to accept any delay or no need to accept any time consuming. Okay, the things will happen instantly. Okay, so that's why we need fast data processing. So that's why we introduced Hadoop. Will introduce not only storage component, not only processing component, and also distributed fashion. So every thing will happen in the distributed manner. That's why the work will complete within the time. Okay. Next one is data locality. So data locality means moving computation logic to the data. So whenever you start the competition, there is no need to go to any place. Just go to the data place and implement the logic. So that's why the logic is there, data is there. Both are available. Next one is feasibility. Feasibility means there is any inconvenient. There is no any inconvenient, even though data is different format, even though data is very large, but Hadoop can able to handle any type of data, any size of data. Next one is data reliability. So reliability means data is stored reliably in the cluster and machines despite failures will happen. Okay, even though failures will happen, no need to human help. No need to human help. It can solve the itself. It can solve the any issue, any problem by itself. That is called data reliability. Next one is Hadoop clusters. Now we are going to start a real topic, Hadoop cluster. You know the cluster. Cluster means a group of objects, a group of similar objects. In this environment, all the data nodes, all the commodity hardware devices will form a cluster. Will form a cluster. So that's why Hadoop clusters have a number of commodity hardware. Those commodity hardware connected jointly, connected together, and then they communicate with very high end machines with those machines simply act as a master, act as a slave. So those across the master and slave machines, we just start the distributed computing or parallel processing. So then you can easily complete the our competition, our task within the deadline. Even though we have thousands of nodes are there, 10,000s of nodes are there, there is no bother about. We can easily complete such computing because of parallel, because of distributed. And also those distributing, why the distributed very easily complete, why the parallel processing is very quickly completing, because of cluster is there. Because of each cluster will support all the required things available at a one place. That's why distributing is complete very easily, and parallel processing is complete very easily. And next one is those clusters like two types. Single node cluster is there, multi node cluster is there. The single node cluster is nothing but like this. This is the cluster. Okay. The cluster has so many things are there. Here these are called racks. Okay. We have n racks are there. N racks are there. Each rack, one name node is there, and also some set of data node plus task tracker. So this is the data node that is called hardware device. This is called task tracker, that is called program. If you want to access the data, we need program, that is called task tracker program. Okay. Next one is, this is a switch. The switch is nothing but we have to communicate with such data node, such name node, that is called network. Okay. You know the network. If the network has some interconnected devices, a router, bridge, switch, gateway, firewall, all the interconnected devices are working is different manner, because those are all interconnected devices play a key role in the environment, in the network environment, because sending and receiving. The same manner, if you want to access the data, not only we maintain the software program that is called job tracker, task tracker, we also maintain the a particular switch. Okay. So this is called one of the cluster. Okay, this is the digital world. Okay, and coming to the, if you want to access the these devices, these racks, we need some set of switches. So those switches connect to the rack switch. The rack switch will able to support to handle the real data or actual data already stored in the data node. Okay, so this is the cluster. Next one is single node cluster. What about single node cluster and what about multi node cluster? So let us understanding single node Hadoop cluster. So single node Hadoop cluster means only single machine. Okay, this entire cluster is based on the single machine. This is called machine. Okay, cluster machine. So it has map and reduce agent is there, and also some HDFS node is there, and also one name node is there. Okay, this is called one name node and some set of HDFS nodes, and also one particular agent is there. This is called a single machine. That's why it is called single node Hadoop clusters. Next one is multi-node Hadoop cluster. So multi-node Hadoop cluster is nothing but multi-nodes are there. Okay, here is name node is there, data node is there, another data node is there, also job tracker is there, task tracker is there, okay, another task tracker is there. This is called master and this is called slave. But here there is no other master and slave, only one machine. There is no slave and master concept. So the previous unit, first unit, you already discussed basic building blocks. So that time we discussed five basic building blocks: name node, data node, secondary name node, and job tracker and task tracker. So that time you discussed name node is a hardware, data node is a hardware, secondary name node is a hardware. And coming to the job tracker and task trackers are software. That is called here. So in this multi-node Hadoop cluster, this is called a HDFS layer. So below the HDFS layer, we have a name node is there, data node is there. That is called, these are called hardware devices. And coming to the above layer, that is called map reduce layer. In this layer, we have only job tracker and task tracker. So job tracker and task tracker also, that is called programs to access the name node data node. Okay. So this is called multi-node cluster. This is called single node cluster. Now, finally, what you can achieve from the Hadoop cluster? What is the importance of Hadoop cluster? The Hadoop cluster, the beauty of Hadoop cluster is robustness. What about robustness? Robustness means ability or strength or quality. So whenever data is going to face any failure or about a particular cluster, maintain thousands of machines, definitely from the commodity hardware devices, failures will happen. Situations will happen in the different manner. Okay, so that time our cluster has a robustness ability is there. That is why whenever the failure will happen, whenever the some dead situation will happen, there is no human help. It can solve by itself. That is called robustness. So data store data reliably, even though the failures will happen. So that is called robustness. Next one is data disk failures. So definitely the disk means you store the data node like a disk. So data disk will going to face failures. But we have a uh, best we have a concept is there, that is called heartbeat concept is there, and replication concept is there. These two approaches we can support to reduce the to avoid the to handle the those failures in the exception case or rare situation. Next one is cluster rebalancing. You already know about scalability. Whenever the competition is going on, thousand machines are not enough, not sufficient. We need more. We need to add more machines, more hardware devices. So that is called cluster rebalancing. We have to balance the cluster. So not only add the new machines, and also whenever the free phase, empty space is there, a particular data node or some set of data nodes. So that time, what will happen? Our threshold level will degrade, will fall downside. So that's why we have to you have to make rebalance in the cluster. Just you can avoid the free space or empty space in data nodes. So that's why the cluster rebalancing will happen automatically to find out the free space of data node, and also we can achieve the good threshold value. Okay, next one is data integrity. So data integrity means you already in the networking environment, you already know what is the importance of data integrity. The changes will not happen. Both the sender and receiver will receive the exact information, exact data. How we can get the data is not changed, not modified, because of we provide some encryption things or other digital signature or other things. But in this place, data integrity, if you want to achieve data integrity, we have to maintain or implement a checksum. You know the value of checksum. Okay, both side, sender and receiver side, will calculate the checksum. The both sender and receiver will get the same checksum result. So then we can finalize the data is not modified. The same concept we are going to implement on each block, and each block of the file. Each block means 128 MB block is there. So whenever you store the data on the data node, first you have to try to identify the or find out the checksum value. Okay. Whenever you start the implementation, you have to calculate the checksum. So that meanwhile you can achieve the data integrity. Next one is metadata disk failures. We already discussed about in the first unit. Whenever the name node or secondary name node will follow these two files, file system image and edit logs. So edit log means so every time we have to modify the things. So those modifications we have to keep, that is called, you have to keep as a edit logs. The FS means file system image. Because of file system is a large, 1 terabyte, 2 terabyte, 3 terabyte. So that's why you can't identify where was the particular block, where was the data node. That's why you have to capture as a single image, that is called file system image. So these file system image maintained by the name node. Okay. So that's why the metadata disk failures, whenever the any failures will happen, there is no bother about, because of we have metadata concept is there, data about data. Because of file system image and edit log will support to know the all the things very quickly. Next one is a snapshot. This is also a snapshot. This is also one of the metadata disk values. The snapshot is nothing but just storing a copy of data at a particular instant of time. So many times data is distributed, many times data is traveled, and so many things will happen, and the data node will be shipped from one place to other place. Any failures will happen, and that any data node is not working properly, simply dead. So that time you have to change the things. So that's why we can't identify where was the real data, where was the particular data. So that's why we have to maintain a snapshot. The snapshot will guide us, will support to trace out, to find out the actual data information. That is called storing a copy of data at a particular instance of RAM. So this is the next topic. Before start the configuring Hadoop cluster, first where we can configuring those Hadoop. First, what we have to do whenever you start the implementation of Hadoop, our particular competition or particular application, first you have to maintain OS, that is called Ubuntu or a particular OS. Okay. Next one is you have to create the Hadoop user. Create the Hadoop user. Next one is install the Java. Okay, JDK. Next one is you have to set up secure shell, secure socket shell. Okay. After complete these necessary things, these requirements, we start the implementation of Hadoop. Download the Hadoop and implement their packages and install their packages in our local system. After installation is completed, you have to focus which environment you have to start the computation, whether it is a standalone mode or a pseudo mode or fully distributed mode. Then start the daemons. Daemons means name node, data node, secondary name node, job tracker, task tracker. The finally we can achieve the distributed mode Hadoop cluster, and such cluster will going to start the working in a distributed manner or parallel manner. So that's why first in this place configure XML and environment files. How to configure XML files, and also how to set up environment. So this is the second unit main intention, main aim is configuring XML files and also setup environment. So this is called configuring Hadoop cluster. Basically, Hadoop can be used on a single machine, that is called a standalone mode, as well as on cluster of machines, that is called distributed mode and pseudo distributed mode. So this is called, we have three modes are there. Okay, these are the three modes. Local mode, that is nothing but standalone mode. So this standalone mode and local mode, only what it how it works, will accept will run as a single process on a single node. Okay, single node is there and single process is there. Okay, Hadoop will run as a single process on a single node. Next one is pseudo distributed mode. The same, both are similar. Local mode and pseudo mode is both are, but Hadoop will run on all services. Hadoop will run all services in a separate process on a single node. Separate process on a single node. Same single node and same Hadoop, but will run the services in separate process, in separate file system. That is called pseudo distributed mode. So in this place, there is no HDFS, only single file system is there, that is called standalone node. And pseudo distributed mode, and here HDFS we are going to use. Next one is fully distributed. So everything is fully distributed. We can use HDFS, and you can use multiple nodes, and we can use many separate processes across the multiple nodes. So that is the difference between local mode, pseudo mode, and fully distributed mode. So these are called local mode. First, now let us understanding what does a local mode. Okay, local mode is nothing but a standalone mode. Local mode is also nothing but a single node mode, and also it is nothing but default mode of Hadoop, and also local job runner mode. Local job runner mode. What it does? By default, Hadoop is configured to run in a no distributed mode. There is no distributions. Only local system is there. Local file system is there. Single file system is there. Single node is there. That's why you don't need distributed mode. Okay, next class we will discuss. Uh, so today we are going to stop the today class. Okay, are you audible? Any doubt is there? Many students are simply leave the class. Please, anybody respond. Okay, tomorrow we will start the local mode Hadoop cluster setup, because of already tired from the morning to afternoon. So that's why I leave the class. I stop the class. Okay, tomorrow we will start the local mode and the pseudo distributed mode and fully distributed mode. Okay, because big data is nothing but only two things are you have to keep in mind. Okay, HDFS and also MapReduce. HDFS is purely hardware, just storing and distributing, and how to give the name to data node. These are all the things are under in hardware. The MapReduce is somewhat interesting to write the program, to implement the program. Okay, the third and fourth and fifth units are focus software. Very lengthy of code is there. Very long code is there to write the map program, to write the reduce program. If you want to maintain compression, you have to write the program. So everything is done by the program. Okay, third and fourth and fifth units are very interesting to write the program. Okay, okay. Thank you all. Now leave the class.